Imagine a world before us, not just dinosaurs, but intelligent beings. Could an advanced civilization have risen and fallen millions of years ago, leaving barely a trace? This isn't science fiction. It's a serious thought experiment known as the Silurian hypothesis. Our planet is incredibly old, roughly 4.5 billion years. Human civilization, in its current form, spans mere millennia. That's a blink in geological time. Consider the vast stretches of Earth's history before humans. Could other intelligent species have emerged, built complex societies, and then vanished? The fossil record is notoriously incomplete. The Silurian hypothesis, proposed by astronomer Adam Frank and climatologist Gavin Schmidt, asks a profound question. If an industrial civilization existed millions of years ago, what evidence would remain today? They named it after the Silurians, a reptilian race from the TV show Doctor Who predated humanity. This hypothesis challenges our anthropocentric view of Earth's history. It forces us to consider that our current technological age might not be unique. The Earth has undergone immense geological changes over eons. Think about the structures we build today: skyscrapers, bridges, cities. How long would these last? Over millions of years, tectonic plate movements, erosion, and natural processes would grind them to dust. Even the most robust concrete and steel would eventually be recycled by the Earth. Fossils are rare occurrences, requiring very specific conditions for preservation. Finding a fossilized city or a technological artifact from millions of years ago would be astronomically unlikely. Most of what we consider permanent is fleeting on a geological timescale. So, if direct evidence like buildings or tools wouldn't survive, what might? The hypothesis suggests looking for technosignatures in the geological record. These are indirect signs of an industrial civilization, much like how we search for biosignatures of ancient life. One key area is the chemical composition of the Earth's strata. An industrial civilization would inevitably leave behind chemical anomalies. These could be detectable even after millions of years. Consider our own civilization's impact. We burn fossil fuels, releasing massive amounts of carbon into the atmosphere. This carbon has a distinct isotopic signature. If an ancient civilization did the same, we might find a spike in carbon isotopes in sedimentary layers from that period. Similarly, widespread use of fertilizers introduces nitrogen into the environment. Nuclear activities, even on a small scale, would leave behind unusual radioactive isotopes. These chemical traces could be preserved in ice cores, ocean sediments, or rock formations. Our modern world is awash in plastics. These materials are incredibly durable, but even they degrade over vast timescales. However, their chemical components might persist as microplastics or unique chemical residues in the geological record. Other pollutants, like heavy metals from mining or industrial processes, could also leave a lasting mark. A sudden, unexplained spike in mercury or lead in ancient sediments could be a clue. These are the kinds of subtle signals scientists might look for. Beyond chemistry, an advanced civilization would physically alter the planet. Large-scale mining operations, for instance, would leave behind distinct geological disturbances. These could be identified as unusual patterns in rock strata or mineral deposits. Massive construction projects, even if their physical structures are gone, might leave behind altered landscapes or unique sediment layers. These are subtle clues, but potentially detectable with advanced geological analysis. To understand what an ancient civilization might leave, we can look at our own impact. Scientists have proposed naming our current geological epoch the Anthropocene due to humanity's profound influence on Earth. This influence is visible in the geological record. Our activities are creating a distinct layer of human-made materials, altered atmospheric composition, and unique chemical signatures. This layer will be detectable millions of years from now. If we can leave such a mark, so could another civilization. The biggest challenge is distinguishing natural phenomena from potential technosignatures. Volcanic eruptions, asteroid impacts, and natural climate shifts can also cause dramatic changes in the geological record. A sudden carbon spike could be from massive volcanism, not ancient industry. Scientists would need to find multiple converging lines of evidence. A unique combination of carbon isotopes, heavy metals, and unusual sediment layers, all occurring simultaneously, would be far more compelling than a single anomaly. The burden of proof is immense. The Silurian hypothesis has profound implications beyond Earth. If it's incredibly difficult to find evidence of a past industrial civilization on our own planet, imagine how hard it is to find one on an exoplanet. This idea informs the search for extraterrestrial intelligence. It suggests that civilizations might rise and fall quickly on cosmic timescales, leaving only fleeting, hard-to-detect traces. This could explain the Great Filter, or the Fermi Paradox, why we haven't found alien civilizations despite the vastness of the universe. Perhaps they existed, but their techno-signatures have long since faded. The Silurian hypothesis doesn't claim that an ancient civilization definitely existed. Instead, it's a powerful thought experiment. It forces us to consider the vastness of deep time and the impermanence of even our most impressive achievements. It reminds us that our understanding of Earth's history is constantly evolving. It encourages us to look at the geological record with new eyes, searching for subtle clues that might rewrite our planet's story. What if we are not the first? The question itself is a journey into the unknown,